system. In front of me here, they have 3D model or a furnace system. This is called the air handler, and this one is called the furnace. So the air handler is pretty much the brand that decide the sequence of the furnace, which component to call, and receiving message from the switch and sensor around the furnace. So before we get into deep about the furnace system, let's go some basics. We need to understand the sequence of operations. So right here, I'm going to write this sequence operation for you to understand. Um, that's here, that is step what a furnace system is received. Typically, is going to receive a call. Okay, so is the first is going to receive a thermostat calling, thermostat calling for heat, and then it's going to check these all the safety, check safety switch, and then it's going to call the draft inducer motor, and after that, it's going to check the pressure switch. So, switch checked, and then when it's passes for structures, it's going to call for ignition, and at this stage, gas valve going to open, and gas valve going to open, and flame sensor coming to check where there is flame in the system or not, to make sure gas is not accumulated. Finally, it says air blower, the big air blower in the system, gonna blow heat into our home. So with these sequences, we're gonna go into the actual the wiring itself. First, normally there gonna be some kind of wire go into the system. It's either 20 volt. It's here. So it's 20 volt. I call it neutral, right? There's a hot wire here. It's come down, and here normally at the front door of the air controller or the furnace there is an interlock switch. Is the interlock. That's the switch. When you open the door, no power come into the furnace. If you open the furnace, you can notice that right at the corner of the door there is a tiny switch. This is the interlock switch, just to protect people and to protect the system. Of course, when the house is open, there shouldn't be power coming inside, right? And after this is go into the L1. This go to L1. Typically, it's just a relay, okay? And in here, I got a neutral Y, go into the section down here. It's called parking, neutral parking, okay? Let me show you what does neutral parking look like. When I turn it up here, this park is in a neutral parking. Different wire of neutral gonna come here and park here. This would make 3, 4, 5, 6 slot. That's allow the setup to put it there. All right. And then what do we know? This is L1, 120 volt coming in. 120 volt coming in. And what is going to next? Inside the board, there's a connection between the relay, and this is called a PR1. And it's called a PR1 is introduce power into the system by connecting to a transformer. This transformer here Going to convert the power from 120 volt, instead of 120 volt, to uh, 24 volt. So there is a neutral wire coming back here. Again, that's going to be parking. Okay, so I would say is that there is, even though there's a 24 volt, so but I use the same color. Okay, uh, okay, I mark it at 24 volt. After transformer, this transformer volt, the hot wire is come to this hot wire here, and it's called the second one and two. Second one and second two. There's another neutral wire, but this neutral wire here is come to the second one, second two. Alright, 24 volt that I have, 24 volt that I have. This is a power go into the air handler. And after this, there is a fuse. Okay, there is a fuse. This fuse is 3 ampere fuse that protect the system from shortage or overcurrent. If there's something happen in the system that creates a spike in the current, this fuse gonna be break. We replace the fuse with a new one, just to protect the handler, because partly we have the air handler is very expensive. The cost for the air handler can range from 300 to 600 or more if it's a new system. Okay, so we need to protect that. So the power coming through here. So I want to change another color to make it easy to see. Now the power coming to here. Okay, over the fuse, and it's go to this part over here. There's a two part, as you can see, as we mentioned, that um, there are two parts, the bottom 6 and part number 8. This part directly connected to a switch, the safety switch. This safety switch, there are two main safety switch, named the loss switch, limit switch, okay, limit switch, and the flame rollout switch. Okay, the responsibilities of this switch, we talk about that later. For now, we know that there is switch, okay? There's switch, and the power comes back to number 8, and from number 8, let's go here. Is these are W, Y, G, C. So these are here gonna connect to something like this, the thermostat outside. In the living room, for example, as in the thermostat, we have Y, G, W, R. Okay, these are here gonna gonna connect with this R in the thermostat. This W here is connecting with this W, yeah, in the handler. This terminal, these two terminal connect with these two terminal. And between the W and R, there is a connection. But this connection is open. When the thermostat is setting to heat and it start cooling, okay, you need air to cool, warm air to cool the room, right? This connection will be closed. Okay, this connection will be closed. Okay, then this power coming in, setting. We have been seeing that the power coming here, through here, through here, through here, up to the here, come back, and this come through is coming in. Now, when the power coming here, this obviously get into the board. So what's gonna do next is that we're gonna see the sequence of operation. The first is thermostat cooling we have just talked about. Okay. The second is check safety switch. Okay. This when the thermostat cooling is system gonna start. Okay, this is switch glow. Nothing happened with the switch. Power can go through. That's good. Then we go to number 3, trap induced motor. There's trap inducer motor down here. Number 3, the board gonna know that, okay, we need to call trap inducer motor. This relay here gonna call the trap inducer motor, and power gonna come through the trap inducer motor. This motor gonna start rolling. Okay, going to start rolling. And when the motor is rolling, it's creating negative pressure inside a this is exhaust fan. Negative pressure inside the exhaust fan. This negative pressure gonna trigger the pressure switch. Okay, here this pressure switch. Okay, there's motive plug right into the exhaust fan, detecting the negative pressure. If there is a negative pressure, it confirms that inducer motor is running. That is good. We now know to step 5. Step 5, the board received a message that, okay, inducer motor is running from the pressure switch. This is called the igniter. Okay, this is igniter here. Hot air igniter. Okay, hot surface igniter. Okay, as hot surface igniter. Where is it? All right, this is cooling. This is hot surface igniter. Go to park here. The relay is sending power to hot surface igniter is in here. It's kind of a ceramic tube. It can heat up at 2000 degrees Fahrenheit. When it heat up at that, the sequence, after that, the sequence is going to go into the gas valve. The gas valve here gonna open, okay? It's gonna open the gas valve to allow air coming in, the gas coming in to this gas chamber. There is some small hole here, depend on the size of the furnace you choose. There may be 2, there may be 3. The gas gonna go through here. Okay. The gas meet the igniter. There will be flame. But in any case, to confirm it, if actually there is flame, then a flame sensor gonna come in to detect the flame. This flame sensor here. Okay, this number 6. Then number 7, this flame sensor here, the tiny white flame sensor here. This like a needle. This sensing if there's a flame. If there is flame, it's gonna send a tiny signal back to the brain of the air handler. And if there is no flame, no signal coming in, the system gonna turn off. Why? Because if the system had to turn off to prevent the situation is that as the step 6 gas valve open, gas keep coming in, the system, if there's no flame, gas can accumulate it inside the house of the furnace, and accidentally, if the fry trigger with the large amount of high pressure gas, your house might be blow off. So it's very dangerous. So after certain second, if the flame sensor doesn't have any signal sent back to the air controller, the whole system gonna repeat the cycle again. Okay, so not until if after you repeat the cycle for a couple times, it's going to a lock mode. The whole system gonna lock down for 3 hours or until the technician come in, turn off the breaker and turn it on again. Okay, assuming that the flame sensor sense the fire, okay, inside the system, and the air blower gonna trigger. So this switch over here, I'm gonna draw the air blower here with a capacitor with different kind of color coming out of the air blower. Each of these wire here can be red, yellow, black, or different color, but each of them indicate different speed. This wire here is connected to cold mode or heat mode down in this relay. Okay, this relay is responsible to turn to cold or heat or different kind of speed in case the system decided to call it. Okay, for example, this case is a heat, it's gonna For example, the red is connecting to heat. It is called the relay gonna turn to heat, and these blower gonna blow air accordingly to the speed. The rest of the Y is connected into the spare. Okay, spare plug is in here. Yes. Okay. So we mentioned A, flame sensor 7. So the whole process I have been demonstrating is the process of the furnace. That's pretty easy. Um, the most intimidating thing is about wiring. Different furnace might have a different wiring color. The only way to understand that is to read uh, the rate plate, the piece of paper that have different kind of drawing and wiring diagrams stick next to the housings of the furnace. So as a technician, we need to understand that. Mm, that's pretty much it. And yes, hope you understand a little bit about the furnace. There are more to talk about. For example, different kind of switch. What is it? And what is the PL1 here, plug number one, and what does it mean? Different kind of part here, responsibility of that, but is for another time. Okay, thank you.